Okay, so building upon last week's lesson where we were computing perimeter, circumference, and area, today we're going to be moving on to two-step area problems. Now, a two-step area problem obviously is going to require two steps for you to solve it, but it is where we build shapes that aren't easily recognizable as squares, rectangles, triangles, and so forth. It's actually where we're taking squares and rectangles and circles and triangles and we're putting them together into new shapes. For example, if we were to draw out something that looks like this, which could be a room, it could be a patio, it could be a garden, it could be several different things. But in looking at this problem, we're going to give some of the sides some dimensions. And when we're looking at this particular shape, we should be able to take and divide this into two geometric figures that we recognize. Now, in looking at this, what do you quickly see? Okay, we may be a square, I'm not sure, but we definitely see two rectangles. Now, how could we make two rectangles? Okay, yes, we could make a horizontal division, or we can make a vertical division. Okay? So, let's assume we're going to do a vertical division. That gives us one geometric figure and another geometric figure. Now, we're going to be computing area. Now, this is a rectangle. And to find the area of a rectangle, we multiply length times width. Now, what is this figure here? Well, it's another rectangle. But what we're missing is dimensions for our base. Now, we know that this rectangle is 8 feet tall. But how wide is it? Well, if we look, we have a measurement for 18 feet from this point to this point. But we need to know what the dimension is from here to here. So how are we going to find out this particular dimension? Well, it's not going to be divided by 2 because we're not aware that we're dividing this into half. Okay? Anyone else? If this is 18 feet from this point to this point, do we know the measurement from this point to this point? We do. Why do we know? Yes. We have this measurement here, which is 10 feet. So if this measurement is 10 feet, then this measurement is going to be 10 feet as well. So if we take 10 feet out of our 18 feet, what does that leave for our base of this rectangle? That leaves 8. So I'm going to clean this up a bit. And I'm going to make this 8 feet as well. So someone said earlier that it looks like we could divide this shape into a rectangle and a square. And you are correct. It is a rectangle and a square. Now, how do we compute the area of a square? Well, since a square is a rectangle, we can multiply length times width. But the area defined, or the formula to find the area of a square is what? Yes, it is side squared. Now all we do is input our numbers. For our rectangle, the length is, it is 24. And our width is, yes, and 24 times 10 is 240 square feet. Now, in computing the area of our square, what is the measurement of the side of the square? Yes, it is 8 feet. And what is 8 squared? It is 64. Very good. Now, the area of our rectangle is 240 square feet. The area of our square is 64 square feet. So how do we find the area of the complete figure? We're going to add the area of our rectangle to the area of our square. And when we do that, we get 304 square feet, or we can write that as 304 feet square. So what we're doing is we're taking a figure and we're dividing it up into recognizable geometric shapes, be it squares, rectangles, triangles, or circles. Okay? Right, we're finding the area of the rectangle, the area of the square, and then adding them together. And that's how we're getting 304 square feet. Okay? Any questions? Okay, I'm going to do one more with you as a model, and then I'm going to give you one to do on your own. Here we have a geometric figure. Let's first see if we have all of the measurements that we need. We know that this is 16 feet. This measurement is 15 feet. This measurement is 12 feet. And this measurement is 11 feet. We are missing one measurement. And what are we missing? Yes, we're missing this particular measurement here. Now, how do you think we're going to compute the measurement of this particular side? Very good. What you're seeing is this side and this side equal this side. So 16 minus 12 gives us 4 feet. Very good. Now the next thing we need to do is take this figure and divide it up into two geometric figures, be it square or rectangle. Now how are we going to do that? Okay, very good. A vertical, let me find a different color here. A vertical cut right here. And when we make a vertical cut there, what are we doing? We're dividing it into two rectangles. And what is the formula for the area of a rectangle? Yes, it is area equals length times width. And area equals length times width. Now in this first rectangle, what is our length? Okay. And what is our width? 12. And what is 11 times 12? Very good. 132. And that would be 132 square feet. Now what about the second rectangle? What is our length? It is 15 times 4. And yes, sir, it is 60. 60 square feet. Now what do we have to do? Yes, we have to take both areas and add them up. So in rectangle 1, we have 132 square feet. In rectangle number 2, we have 60 square feet. And when we add those together, we have 192 square feet. Right, now if we were going to compute perimeter, that's something entirely different. The perimeter is a measurement of the outside of the figure. So if we were adding up perimeter, we would say 16 plus 15 plus 4 plus 12 plus 11 plus 4 as well. Okay? Right. Perimeter is the measurement on the outside of a geometric figure. Area is a measurement of the inside of a geometric figure. Now, speaking of area, Israel, what are some practical applications of finding area? What's something in our real life? What's an occurrence when we would actually want to compute area? Flooring, exactly. My mother-in-law just got new carpeting, and they sell carpeting by the square yards. So to be able to compute, if you had a rectangular room, then you would have to be able to, you could measure your length and your width, and then be able to find your square feet, and then you'd convert it into square yardage if you were buying carpeting. Yes, sir. Yes, sir. Absolutely. So, area, hello, real life applications of finding area then would be flooring. Any other real life examples of any time you'd want to compute area? What else could you do in a room? We've already remodeled it with carpeting. Okay, let's say we're going to paint the ceiling. Okay, so if we're going to paint the ceiling, we can compute the area of our ceiling. What about our walls? We might want to put up some wallpaper. Okay, there we would also have to be able to compute area as well. Okay, so those are all real-life examples of when you would want to compute area. Now I'm going to give you a figure that I want you to compute on your own. Now, the first two things that you need to do is determine, do you have all the measurements of the sides? And then, how are you going to divide this geometric shape into something that you recognize? Now, do we have all of the measurements that we need? No, we do not. What are we missing? We need the measurement of this top section. Now, how do we determine the length from this point to this point? Okay, so you're saying 21 minus 9. Very good. So 21 minus 9 is? Very good. So this unknown piece measures 12 feet. Now, you may have used a horizontal line. You may have used a vertical line. I would use a vertical line because what leapt out at me is, with this being 9 by 9, this makes a square. So I would use a vertical line then to divide these into a square and a rectangle. Now, what is the formula to compute the area of a rectangle? Very good. It is length times width. What about a square? Yes, ma'am. It is side squared. Now, looking first at our rectangle, what is our length? Yes, sir. And what is our width? 12. And what is 15 times 12? Thank you. Now, keep in mind that's 180 square feet or 180 feet square. Now let's look at our square. What is the measurement of a side? 9. And what is 9 squared? No, it's 180. So then we take the area of our rectangle and the area of our square, and we add them together. Right. And it is 261 square feet, or it is 261 feet square. Either way you want to represent that answer is fine. Now, let's look at a figure that's a little more difficult. Maybe something that contains something other than a square or a rectangle. Now here we have a shape that can be divided into what? Very good. A triangle and a rectangle, because we can make a horizontal cut here. Okay. Now, if we're looking at the rectangle, the formula to find the area of a rectangle is what? Yes, it is length times width. What is the formula to compute the area of a triangle? Well, we mentioned that there were two different formulas that you could use. One, you could say 1/2 times the base times the height, or you could say base times the height divided by 2. Whatever you're most comfortable with, you can use that to compute the area of a triangle. Now, looking back at our rectangle, what is our particular length? Yes, 21. And what is our width? Yes. And 21 times 10 is, yes ma'am, it is 210 square feet. Now let's look at our triangle. That was a given. I was telling you how tall the triangle is, the height. I gave you all the dimensions in this figure. Now, in computing the triangle, do you want to use the first or the second formula? Second, okay. So the area is equal to the base times the height divided by 2. Now, in the triangle, what does the base measure? It measures 21 feet. The base of the triangle is equal to the base of the rectangle. Now, what is the height of the triangle? 9. And what is 21 times 9? Yes, ma'am, is 189. And 189 divided by 2 is 94.5, or 94.5. Now, to compute the total area of the figure, we would take the measurement of the rectangle, the measurement of the triangle, and we would add them together. And it would be 304 5/10 square feet, or 304 5/10 feet squared, however you want to represent that. Okay, here's an odd shape. What are we combining together to get this shape? Very good, D. If we draw a vertical line here, we have a rectangle, and what did you say this was? It is half of a circle. Now, what is the formula to find the area of a rectangle? Yes, sir. It is length times width. And what is our length? And our width? And 14 times 18? 252 square feet. Now, if you do need a calculator, you should have a calculator inside your desk. Now we're going to deal with this half circle. Does anyone know or remember, you should know, remember the formula to compute the area of a circle? Pi r squared. Very good, Israel. I'm proud of you. Area equals pi r squared. Now, That's going to give us the area of the entire circle. Once we're done, we're going to have to divide that in two because we only have half a circle here. Okay, now, what did we say pi was equal to? 3.14. Okay, let's use that. What else is it equal to, Cheyenne? Yes? 22/7, or what would it be equal to as a mixed number? No. 3 1/7. So pi is equal to 3 1/7, or 3.14, or 22/7. Okay. What is the most popular? Generally, 22/7 is what you will find yourself using more often than not. Okay, but in this example, we're using 3.14. Now, what is the radius of this circle? It would be 7. Why is it not 14? Very good, Israel. 14 is a measurement of the diameter. And as we looked last week, if you have the diameter and you want to find the radius, you divide by 2. So our radius would be 7. And what is 7 squared? It is 49. And what is 3.14 times 49? It is 153 86 hundredths. But now that's for the entire circle. Now what are we going to do to compute half of a circle? Well, we're going to divide it by 2. And when we do divide by 2, we're going to get 76 93 hundredths. Now what do we do? Yes, we add the rectangle and the half circle. The rectangle is 252 and the half circle is 76 93 hundredths. And that's going to give us 328 93 hundredths square feet, or 328 93 hundredths feet square. Yes, so any one of these occurrences or appearances would be fine. Now, what we've been doing so far in solving these two-step area problems is we've been taking the measurement of one geometric figure and adding it to the measurement of another geometric figure. Now, let's turn it up a little and look at it a different way. Now, this is a wall in your bedroom. And you're going to be wallpapering this wall. And this wall measures 8 feet by 15 feet. Now, if that was a solid wall, it would be no problem. We would multiply length times width. But, Israel, this is an outside wall, and we have a window. Yes, we have a window. And this window measures 5 feet by 3 feet. Now, Israel, obviously, you're not going to wallpaper over your window. So what we're going to have to do is compute the area of the wall and subtract out of that the area of the window. Okay? Now, how are we going to compute the area of the wall? So we're going to multiply the length times the width. And what is the length of our wall? Yes, it is 15 feet. And the width of our wall is, yes, 8. And 15 times 8 is 120 square feet. Now let's compute the area of our window. Now our window is shaped like a rectangle. And to compute the area of a rectangle, we multiply, yes, length times the width. Now what is the length of our window? And what is our width? 3. And what is 5 times 3? Now here we have to find the difference. And when you find the difference, you subtract. So we have 120 square feet in our wall, less 15 square feet in our window. That's going to give us 105 square feet, or 105 feet squared. Brandon, it's an either-or situation. Yeah, you could say 5 times 3 or 3 times 5. You're still going to get the same answer. Okay? Now, I'm going to give you one that I'd like for you to do on your own. And if you would like to, you could partner up. D, if you want to partner with Israel. Jamie, if you want to move over here. And Jen, if you want to partner with Cheyenne. Brandon and Molly, obviously, it goes without saying, you all are going to partner up. Okay, so I'm going to, now we're going to look at, we have a deck on the back of our house, and we're going to paint our deck. But on our deck, Israel, we have a permanent barbecue. So this is what our deck looks like. And our deck measures 9 feet by 22 feet. And then we have a permanent brick barbecue that measures 3 feet by 7 feet. So I want you to be able to tell me what area of our deck are we going to paint. What is the formula to compute the area of the deck? Very good. And what is our length and our width? Okay. And 9 times 22? 198 square feet. Now, how do we compute the area of our barbecue? Yes, it is length times width, because our barbecue is in the shape of a rectangle. What is the length of our barbecue? And our and our width is 3. And 7 times 3 is 21. Good morning. So, we're not obviously going to paint over the barbecue, so we have to find the difference. We have to find the difference between the deck and the barbecue. So that would be 177 square feet or 177 feet square.